Hello everyone, I'm Ishira Mehta Desai, a senior EC2 Core GTM specialist based out of San Francisco. This is CMP 303, selecting the right Amazon EC2 instance for your workloads that will cover high-level EC2 related concepts and offerings, EC2 discovery process, and tooling that will be accompanied with a demo. I hope to have a little something for everyone. Today I'll be walking through the following themes: how to get started on Amazon EC2, which will be followed with a detailed breakdown of Amazon EC2 instances, how to decide on the right Amazon EC2 instance for your workloads, EC2 Instance Discovery, which is a one-stop tool for the EC2 instance selection process, and that will be finally followed with a demo. Let's start with a customer question that is often raised during the initial EC2 discovery phase, which is, I'm in the process of selecting an Amazon EC2 instance for my workload, and to get started, I'd like an overview of Amazon EC2 Instance as a service offering. Today we offer the broadest and deepest compute platform with over 350 instances supporting a wide variety of processors and architectures to choose from. AWS has invested in new capabilities over the last year, such as faster processors, and introduced new instance types for accelerated computing and for all supported processor types. You can also add options such as the Amazon Elastic Block Storage to provide greater performance and storage flexibility, Amazon Elastic Inference to reduce costs of running deep learning inference workloads by up to 75%, and Elastic Fabric Adapter to run applications requiring high internode communications at scale on AWS. As all of this comes together, AWS will continue to bring new instances to market to support virtually every workload and business need. The next common question we get asked a lot is, I'd like a detailed breakdown of the different Amazon EC2 instances by workload type. As I mentioned earlier, AWS offers over 350 instances that are targeted for different types of workloads. Let's break that down by looking at the M5DX large as an example. Every server has 4 key computing resources, that is, the CPU, memory, networking, and storage. Some workloads are more CPU intensive, while some are more memory intensive, and so on. So AWS created different SKUs or instance families, which is the letter M on your left. So as new technologies were added to EC2 instances, AWS introduced instance generations to expose these innovations, which is represented by letter 5, and then added new additional capabilities like CPU capabilities, memory capabilities, network capabilities, which is represented by the letter T in this case. Last is nothing but sizing of the instance, which is nothing but a t-shirt sizing of your instance, and that is represented by X large in this case. Something to keep in mind is that every instance size in an instance family will have the same vCPU ratio, but every instance size will have twice the number of CPU, memory, and storage resources compared to the previous size. That is, an M5D X large will have twice the resources compared to a M5D large instance. Now, this is a high-level overview of AWS's latest instance offerings based on workload types such as general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. Every year, AWS delivers the absolute latest and greatest platforms to build applications on. I won't go through each and every instance that was released this past year, but I will definitely point out a few highlights as we go through the next slides. Beyond the operating system, AWS provides you with the choice of processor and architecture to build the application you need with the flexibility you want. AWS believes that by providing greater choice, customers can choose the right instance type to power their application and workload. AWS has 3 processors to choose from. The first one is Intel. Since 2006, AWS has had a strong standing relationship and partnership with Intel, and their processors have been essential in delivering some of our most powerful instances. EC2 instances that are powered by the Intel Xeon Scalable processor have the largest breadth, global reach, and availability of compute instances across all AWS geographies. The next is the AMD EPYC processor, which was released in 2018, and it is seeing strong adoption due to its lower costs compared to AWS Intel-based instances. The last one is AWS Graviton 2, which is AWS's very own processor that was launched last year at reInvent and has ignited the ARM ecosystem for a variety of workloads. Customers are doing some amazing things with EC2 Instance portfolio, and some are already testing their applications with these new instances and processor types. AWS has built some incredible instance types on Intel, and there is a great deal of diversity in this space. So let's first dive deeper into some of the Intel-based instances. I'd like to spend the next few minutes in diving into our Intel-based high-performance compute offerings. The first one is the Amazon EC2 C5 and C5N instances that deliver high performance at a low price per compute ratio for running advanced computing workloads such as high-performance web servers, high-performance computing, batch analytics, distributed analytics, and deep learning inference, to name a few. These instances deliver up to 25 Gbps of network bandwidth and up to 19 Gbps of dedicated bandwidth to Amazon EBS. The C5 instances leverage the fourth generation of the custom Nitro card and also leverage the Elastic Network Adapter to deliver up to 100 Gbps of networking bandwidth. And they deliver up to 19 Gbps of dedicated bandwidth to Amazon EBS. The C5N 18x large particularly supports the Elastic Fabric Adapter to run tightly coupled HPC workloads at scale on AWS. These instances are ideal for running network-intensive applications such as HPC workloads, data lake and analytics platform, and network appliances. The next set of instances that I'd like to cover is the first one is the Amazon Z1D instance that delivers high single-thread performance due to a custom Intel Xeon Scalable processor running at up to 4 GHz all-core sustained frequency, which is the fastest instance in any cloud. They support up to 25 Gbps of network bandwidth and up to 1.8 terabytes of local NVMe storage, resulting in up to 14 Gbps of dedicated EBS bandwidth to both encrypted and unencrypted EBS volumes. The Z1D provides both high compute performance and high memory, which is ideal for running workloads such as the electronic design automation, gaming, HPC, data analytics, among others. The next and the last instance that I would like to talk about are the EC2 high memory instances that offer 6, 9, 12, 18, and 24 terabytes of memory in an instance and are available as bare metal options on EC2 dedicated hosts. The EC2 high memory instances are EBS optimized by default and offer up to 38 Gbps of dedicated storage bandwidth to both encrypted and unencrypted EBS volumes. These instances also deliver up to 100 Gbps of aggregate network bandwidth and are purpose-built to run large in-memory databases, including the production deployments of SAP HANA in-memory database in the cloud. Now let's take a look at AMD processors. If we look at EC2 instances that include AMD processors, there are a few things that really stand out. First, Amazon is laser focused on delivering the best possible performance at reduced costs. EC2 instances that are based on AMD processors continue that heritage and are available at least 10% reduced costs compared to AWS Intel-based instances. Another benefit that AWS offers customers is the ability to choose their instances on the processor that best fits their workload. Because of this, AMD-based instances are offered along with Intel Xeon-based processors and Graviton 2 ARM-based CPUs. There is one more feature with AMD that really stands out, which is making it a seamless experience for customers. Towards that goal, you will find that if you're using, for example, a C5 instance, you can easily migrate to a C5A instance. The same holds true for M5, R5, and T3 instances. So for almost all instances, the migration is as simple as selecting a different instance at launch without the need to recompile the instance. At reInvent 2019, AWS announced the second generation of the Graviton 2 processor, which is Graviton 2. Let's take a look at that now. If AWS Graviton 2 is the second generation of ARM chips that are coming from Annapurna. Customers gave us feedback that supporting ARM was a great step forward and that our first generation of Graviton processor was a good starting point. However, they did push us to innovate faster and provide better performance so they could use some of these instances for more demanding workloads. These CPUs are built utilizing customized 64-bit ARM Neoverse cores with the most advanced 7-nanometer custom silicon process, which represents our continued investments in building custom silicon solutions. The AWS Graviton 2 processor delivers up to 7x better performance, 4x number of compute cores with more support for ML, video, and HPC, and 5x faster memory than the previous generation, including DRAM encryption. The Graviton 2 processor supports based instances support up to 64 vCPUs, 25 Gbps of enhanced networking bandwidth, and up to 19 Gbps of Amazon EBS bandwidth. And this is enabling customers to do some amazing things and bring better workloads to our ARM ecosystem. Now, the AWS Graviton 2 processor is offered in 4 new instance types, which is the M6G, C6G, R6G, and T4G. And they all deliver up to 40% better price performance over comparable current generation x86-based instances. The M6G is suited for general purpose workloads, just like the rest of the M family, while C6G is better suited for compute-intensive workloads, R6G for memory-intensive workloads, and the T4G is the new generation, low-cost, burstable general purpose instance type. Now, the MCNR instance type also support local NVMe storage options as well as support bare metal options. Now, let's dive deep into the broad selection of accelerators for machine learning workloads. AWS has been working with NVIDIA to bring the most advanced and highest performing GPU technology to the cloud. FPGAs are hardware devices that need to be programmed, that is, they have no instruction set or predefined data path but provide dramatic performance improvement. Let's take a look at the instance types that are powered by these accelerators. The P4D instance provides access to up to 8 NVIDIA A100 GPUs in a single instance with support for NVLink for peer-to-peer GPU communication and NVIDIA GPU Direct. They deliver up to 2.5x the deep learning performance and up to 60% lower cost to train models as compared to P3 instances. The P4D instances are best for use cases that include deep learning in training, HPC simulation, financial computing, and batch rendering. We also provide powerful GPUs for inference and virtual workstations with our G4 instances. The F1 instances are highly performant, easy to access, and fully customizable. What this means is you can directly access the FPGA hardware with a few clicks and accelerate application performance with over 30 times compared to general purpose CPUs. The F1 instances are best suited for workloads such as financial computing, genomics, compression and security algorithms, and search and analytics. Moving on, let's take a look at AWS Inferentia, which is a high-performance machine learning inference chip custom designed by AWS. So we've coupled the Inferentia chips with the latest custom second-generation Intel processor and with up to 100 Gbps of networking bandwidth to deliver high-throughput inference. This powerful configuration enables X1 instances to deliver up to 10x lower inference latency for real-time applications, 2x higher inference throughput, and up to 2000 tera operations per second, which allows you to run concurrent requests more quickly. Also, the Infun instances offer up to 40% lower cost than any Amazon EC2 GPU instances, which were already the lowest cost instances for machine learning workloads in the cloud. They also enable you the freedom to choose how to deploy your inference application, which means you can use all the popular ML frameworks, including TensorFlow, PyTorch, and MXNet. After receiving a detailed breakdown of our different EC2 instances based on workload types, customer almost always asks, how can I decide on the right Amazon EC2 instance for my workload? As the title reads, Amazon EC2 instance selection is a continuous process based on evolving customer needs and business needs, and therefore an important prerequisite to the instance selection process is you need to know your application or workload, for which you need to answer these following key questions. The first one is, what are my business requirements? Some examples of those could be high performance, cost optimization, or meeting your operational SLA. The second question, which is also very important, is what are my key bottlenecks that need to be addressed to meet my business requirements? These could be in terms of disk, I/O, memory, network utilization, and if there are multiple, what we suggest is to decide on the most important one for your business. Once you have these questions answered, you can then move on to selecting the right Amazon EC2 instance for your workload. Now, just a disclaimer here, please don't get scared looking at this flowchart. I know it looks a bit too much, but trust me, it's just a quick one-stop place to help you decide on the right Amazon EC2 instance for your application, depending on your business requirements and key bottlenecks. So some of these constraints could be, the first one is storage-based constraints. So for those constraints, customers have options to choose from D2, D3, or D3 EN instances for high disk throughput, H1 instances for HDD-based storage plus disk throughput, and I3 for high I/O. For network constraints, customers can choose from M5N for general purpose workloads, R5N for memory-based workloads, I3EN for storage-based workloads, and C5N for compute-based workloads. Now, depending on your memory requirements, customers also have options to choose from R5 instances, which offer up to 768 gigabytes of memory, X1 instances, which offer up to 4 terabytes of memory, or the U-metal instances that we discussed earlier that offer up to 24 terabytes of memory. For AI/ML-based workloads, customers can choose from P3DN or P4D instances for general purpose AI/ML workloads, F1 instances for FPGA workloads, and Inf1 instances for custom AI/ML workloads. For graphic-based workloads, customers can choose from our G3DN or G4 instances, depending on the number of GPUs required. Now, depending on your CPU requirements, that is, if you need more vCPUs or more frequency, you have the options to choose from our C5 or Z1D instances, respectively. Lastly, and the most common constraint that we hear from customers are cost-based constraints, and for that, customers now have options to choose from our Graviton 2-based instance offering, which are this M6G, R6G, T4G, or C6G, or they can choose from our AMD-based instances, which we discussed earlier, as they offer lower cost compared to Intel-based instances. Moving on, let's see, there could be a situation where you're unsure about your key application constraints. In that case, this is what we recommend. You start with the best guess instance, instrument it to win resource utilization metrics, and observe it by performing a load test. After that, you find a constrained resource, which is the resource that's closest to full utilization. For example, when utilization is measured over a relatively long period of time, that could be within minutes or seconds, a total utilization of, say, 70% may become a bottleneck. Lastly, you need to size the instance according to the constrained resource using AWS tools. Now, we often come across customers talking to us about specific use cases, which I thought would be worth mentioning. The first one is, let's say your application runs on Linux and is based on an open source software or framework. In that case, what we recommend is to use our new AWS Graviton 2 based instances, as they have a better price per performance ratio. Let's say you need instances but without any virtualization. In that case, use any of our bare metal instance offerings. You need a lot of cores but not a high floating peak performance. You can use our AMD based instances. Now, if you need low cost machine learning inference in the cloud but with high performance, use our Inf1 instances. And lastly, for FPGA based workloads, you can leverage our F1 based instances. The instance selection process that I discussed earlier is really helpful for customers to be informed about the available list of instances based on their constraints. But this process can become cumbersome when customers need to do a side-by-side comparison of instances that meet their requirement and narrow down to a particular instance. That is why we have customers almost always asking us if AWS provides an easy way to discover, locate, and compare EC2 instances. And the answer is yes, we do. Let's see how. As AWS is focused on providing the broadest and deepest compute platform to enable choice, we're also investing in making this platform easy to use so that choice does not become a complexity. Keeping this in mind, AWS launched the EC2 Instance Discovery last year to optimize instance selection for planned workloads. With EC2 Instance Discovery, all customers need to do is specify their hardware requirements, and EC2 Instance Discovery will give customers a comparable list of instances to choose from to review and to review across price, location, and performance that fit their workload requirements. Customers thus have a single source of truth for latest instance types, attributes, regional and zonal offerings, and pricing. Also, this service offers a search and discovery experience that is powered via the AWS EC2 Management Console, and it enables programmatic access for customers to easily find and compare EC2 instances. To sum it all up, EC2 Instance Discovery enables lower costs, optimizes performance, and enables you to get started quickly. Here is a slide that walks through when does the EC2 Discovery tool specifically come in handy. Now, a common concern that we get from customers while they decide on the right EC2 instance for their workloads is, with over 350 instances available, we are finding it really challenging to select the right instance to run our workload. We do not wish to over-provision our compute and at the same time not under-provision it, as that will impact our application performance. To resolve these concerns, customers now need to answer just one common question, and that is, do you understand the hardware requirements for your application but feel unsure of which instance can be cost optimal to fulfill the compute required? If the answer is yes, which is in most cases, customers can just leverage our EC2 Instance Discovery tool to review instance recommendations for workloads they plan to run. All they need to do is specify hardware requirements, as I mentioned earlier, and compare instance types based on CPU, network, memory, performance, and so on. Now let's go through a demo of how to use EC2 Instance Discovery via the EC2 Management Console and API. First, navigate to the Instance Type section in the EC2 Management Console and click on the gear icon to your right. You can now customize information that is available in the table by toggling on or off the attributes that meet your workload requirement. For example, in this screenshot, we have turned on the instance type, vCPU, and architecture attribute. Next, to limit the list to only instance types that meet your requirement, search or set filters in the search bar. You can input these search terms directly or use filters to filter specific attributes. For example, in this screenshot, setting current generation to true displays all the current generation instance types. Similarly, setting the search bar or the filter to metal, it displays all the metal type instances. Next, you can also use ranges in the min and max filters. For example, the min memory filter will display all the instances with at least the minimum memory required. Now, to see all attributes for one instance type, simply click on the checkbox to the leftmost column. To compare multiple instance types, select them all. In this example, I have selected the two least expensive instances that meet my workload requirement. The selected instances are shown side by side in the details section for easier comparison. The bold text in the details pane, as you see in this screenshot, highlights attributes that are different for the compared instance types. Now, this console experience that we discussed earlier is powered by two new APIs, which is the Describe Instance Types and Describe Instance Type Offerings. You can use these APIs individually or in combination to return information about a specific instance or to return multiple instance types that meet your requirement. Now, similar to how you set filters in your console, the API responses can be filtered as well. Here are some examples to help get you started. For example, the first command in the AWS CLI screenshot returns all the current generation instance types. You can also use partial strings to filter responses, especially if you have fields with multiple parts, as seen in the second screenshot. In that screenshot, the AWS CLI command yields all the metal instances that are i3 metal and z1d metal family. Now, to sum it all up, I walked through EC2 instances as a service offering, their evolution on AWS, and how instance selection is a continuous process. If I could boil this down to a single theme, it would be AWS EC2's team ability to thrive while successfully implementing change based on evolving customer needs and lessons learned. I'd like to conclude with this quote from Jeff Bezos, because change is inevitable and something that our most experienced customers live by. Thank you for watching, and please complete the session survey at the end of this presentation. Thank you.